So certainly of vital importance to our existence of humans is the processing of language, and it's absolutely necessary for us to learn about our place in human society and to establish our place in human society and to be able to communicate with other humans. So language processing is largely found in the left cerebral cortex in most individuals. Well over 90-95% of individuals have language processing on their left side only. The Wernicke's area, that's found mostly in the temporal lobe, but also a tad bit in the parietal lobe, is an area of vital importance in this. I've kind of danced around it up until now, but it is where the definitions, the context for words is found. So this is where we will actually understand what a word means after we hear it or see it. This is where it will come to. And then Broca's area is all about establishing the correct emotional context for this word, and then beginning to implement how we're going to say the word, all the massive amount of calculations that have to go in to figure out which muscles to move, how to move them, and deliver that information to the premotor cortex. So I've broken this down into a series of steps. It's certainly a prime candidate for a short answer on the exam. And so we're going to, of course, what I'm describing here is the ability to speak a word after reading it. So I'm up at a lectern, and I've got my speech on notes or slides or graphs or something, and I'm going to be reading that speech. And of course I visualize it. That information goes back to my occipital lobe, and then it will move forward or rostrally to my visual association area, where I begin to recognize the patterns of the words that I had written down. So as I begin to compare the patterns of those words to the patterns I have in my little files in my visual association area, so I'll have many, many little files, and I'll be comparing what I'm seeing with those files, and then eventually I'll send that information to Wernicke's area, where I report the pattern that I've seen, and then I can associate that with the understanding of the word, with its definition. Now I know what it means, and Wernicke's area will send that information to the frontal lobe, where Broca's area is found at, and Broca's area then will convert the understanding of the word, combine it with its context and its emotion, and then forward that information to the premotor cortex that will then establish what muscles I need to tense, how I need to arrange my glottis, my breathing rate, all of these incredibly complex things just to say a word, sends the information to the motor cortex, which then, of course, delivers the commands to execute them. So here we see some functional MRIs of this approach. Here we have hearing words, that would be where you'd expect in the temporal lobe, and then seeing the words in the occipital lobe, generating the words, that's in the Broca's area, generating the words, and then actually speaking them as the motor cortex, right? So again, Wernicke's area is where we recognize spoken and written language. When we speak, Wernicke's area is going to govern the rules behind the phrasing that we'll be using, and then transmits all these plans to Broca's area that begins to get the motor programs ready, and then also gets information from other areas, and then eventually sends that, even though this says to the primary cortex, Broca's area will also interrelate with the premotor cortex. And we see that sequence of events here: the primary visual cortex, the visual association area, the Wernicke's area, Broca's area, the premotor cortex area right in here, and then the motor area gets its responsibility assigned to it. Okay, so let's look once again at the functional regions of the cerebral cortex. We have the frontal lobe here that contains the motor cortex, the premotor cortex, or the motor association area, Broca's area, the prefrontal cortex making up most of the frontal lobe, and then down here we see some other information being accomplished. In the parietal lobe, we have the primary somatosensory cortex found in the postcentral gyrus, the somatic sensory association area, and then the primary taste cortex found way down here at the base of the postcentral gyrus. The occipital lobe is primarily all about visual processing, and then we have the temporal lobe where we have Wernicke's area. We've got the facial recognition structures, we've got the hearing cortex, as well as the smell cortex. So what happens? How do we know all these things? Once again, we're going to look at people that have lesions, that have damage to the areas that will give us guidance into what they normally function as. And so if you have a deficit or lesions in particular areas of Wernicke's and Broca's areas, then you are going to call that an aphasia because it will affect speech. And so there is Broca's aphasia, where you have very slow speech. And when I say slow, it is really, really slow. Very difficult to figure out a word to say, and you generally aren't real precise with those words. When you are in Wernicke's, when you have Wernicke's aphasia, the words you're generating are useless because you haven't combined the meaning with the word. And so you can't comprehend written or spoken words. It's incredibly frustrating for these individuals because they can hear that they're saying garbage, and so it's just a bad situation. Then there is anomic aphasia, where you can speak and understand speech perfectly fine, but you can't identify words or pictures. So finally, in the topic of chapter 14, before we get to the cranial nerves, let's talk about lateralization. And this is the idea that there are specific functions assigned to specific sides of the brain. Now again, it's never that easy. Sometimes they overlap quite a bit, and we'll talk as much about that as we can. And so the left hemisphere is called our categorical hemisphere. Again, language is found here, math reasoning, analytical reasoning. So this is if you're strong in math and science, and generally your left hemisphere is more dominant. And what it does is it fragments arguments, fragments situations, fragments equations, and then begins to analyze them in a sequential manner. This is where usually, because it's called the categorical hemisphere, it's largely our decision-making hemisphere as well, whereas the right hemisphere is our so-called representational hemisphere. And here you're more touchy-feely, more holistic about your approach to life. And this is where imagination is embedded for the most part, insight, musical skills, not appreciation of music necessarily. That can be found throughout many areas of the brain, but your musical skill, the actual acquisition of these, is done by the right hemisphere, as well as anything artistic. Your spatial patterning is formed in the right hemisphere, and where you compare these special senses is found here as well. And finally, your recognition of faces, and when you hear these voices, is he being sarcastic, is he being serious, what is the outcome here? That'll be largely determined by the right hemisphere. But it can be overruled by the left. And sometimes in some people there are arguments between the right and the left, and that can get interesting. Certainly something that you should research if you're at all interested on it. So lateralization is highly correlated with whether you're right-handed or left-handed. And right-handed people, the left hemisphere is the one that we've been talking about, the categorical one. And left-handed people, the right hemisphere has more assignments being categorical than in the left, but it's still not an overwhelming percentage like you see with right-handed people. Lateralization does progress with age. It is not as pronounced in little kiddos, and there is more lateralization in males than in females, and a lot of this can do with the idea or the notion that there is more equalization, and the corpus callosum is better connected between right and left halves of the brain. And some evidence indicates that the corpus callosum is larger in females than it is males, so there's much less lateralization because of this. Whereas in males, it's typically the corpus callosum isn't as well interconnected and is smaller, And so one side tends to dominate much more profoundly, and that's the left side generally. And so that males will suffer more if one side is damaged over another. So here we see the breakdown of lateralization, and you can see how the two sides compare in their presentation to the world.